Good day, everybody. Hope you are doing great today. So we are going to work on some area under the probability distribution curve. So here I go. A population has a mean of 32 and standard deviation of 6. Assume the population is normally distributed. Approximately what percentage of the population is between 26 and 38? So let's do part A. We'll assume it's a bell-shaped curve because it's normally distributed. Let me erase that and do a better job. Okay, so the mean is mu, population mean is 32, and population standard deviation is sigma, is 6. And the two numbers we have been given are 26, which is less than 32. So it's on the left of 32. It's 26 over here. And 38 is greater than 32, is on the right of the mean. So we have been asked to assume the approximately what percentage of the population will fall between 26 and 38. So the first thing we will do is find the distance of 26 from the mean is equal to 32 minus 26 is equal to 6. And distance of 38 from the mean is also 38 minus 32 is 6. So the distance, so the question is how many standard deviation away from the mean? Away from the mean is 6. Is the distance 6. And that is distance 6. Remember, the standard deviation is 6. So distance divided by standard deviation is 6 over 6 is equal to 1. So if I move this a little bit up, what does mean that? What does this mean? It means both 30, 26, and 38 are located away by 1 standard deviation. One standard deviation from the mean. Now use empirical rule. Empirical rule for normal distribution. Approximately 68% of the population Oops. Population will fall within one standard deviation of the mean. So the answer to the question of the mean. So answer is this. Answer for part A. Approximately 68% of the population will fall between 26 and 38. So let me highlight this. Okay. So that's your answer. And here I use the empirical rule, which states that for normal population, approximately 68% of the population will fall within one standard deviation of the mean. Remember, this distance is sigma. This distance over here is also sigma. That's why 68% of the population will fall between 26 and 38. Now let's move up a little bit and solve part B. Assume the population is bell-shaped, which means standard, which is approximately normal distribution, bell-shaped. And we have been asked between which two values will approximately 95% of the population fall. So we will again use the empirical rule in this case. Excuse me. So we are going to do now part B. Let's change the color. Part B. Using empirical rule for bell-shaped distribution. For bell-shaped distribution. Approximately 95% of the population will fall within two standard deviation of the mean. Deviation of the mean. Okay, so we know our mean is 32. Let's do it over here. Mean is 32. Sigma is 6. So 2 times sigma will be 2 times 6, which is 12. So mu plus 2 sigma, sorry, mu standard plus 2 sigma is equal to 32 plus 12 is 44. And mu minus sigma minus 2 sigma is 32 minus 12, which is 20. So the answer for part B answer. Approximately 95% of the population will fall between 20 and 44. Okay, 2 standard deviation from the mean. So let me highlight the results. So this is one number 20, the other number is 44. Okay, so please do not quit right away. I'll give you an important tip at the end of this program. Okay, so please keep watching, and if please subscribe to my channel, Math Science Topia, where I've solved all kinds of stat problems just for you. Okay, let's take a look at part C quickly. If we assume the population is not bell-shaped, at least what percentage of the population will fall between 20 and 44? Okay, so let's change the color of the ink and let's move this a little. This is part C. Part C. Population is not bell-shaped. We already know oops, let me correct. We already know 20 and 44 are located 2 standard deviation away from the mean. 2 standard deviation away from the mean. Away from the mean. So use Chebyshev's theorem in this case. Use Chebyshev's theorem. Chebyshev's theorem. Chebyshev's theorem. Because the population is not bell-shaped. Is not bell-shaped. And Chebyshev's theorem states Chebyshev's theorem states that at least 75% of the population will fall within 2 standard deviation of the mean. Within 2 standard deviation of the mean. Deviations of the mean. Okay, so if I create some space, so therefore at least 75% of the population will fall between 20 and 44. So the answer to part C is at least 75%. So let me highlight that. Okay, so that is the end of the problem. The tip I wanted to give you, the important tip is that if you have a bell-shaped distribution, then remember the rule is 68, 95, and 99.7. 68 for 68% for one standard deviation from the mean, 95% for two standard deviation, and 99.7 for three standard deviation. And if the distribution, population distribution is not normal, then we use Chebyshev theorem, which states that uh, at least 75% of the population will fall within two standard deviation of the mean. Okay, so I will stop here today. If you have any question or comment, write me a note. I'll get back to you as soon as possible. If you like this video, please give me a thumbs up. I appreciate that. If you like this video, share with your friends. You and your friends, please subscribe to my channel, Math Science Topia, by hitting the red subscribe button. And please let YouTube know that every time I upload a new problem, you will get a notification. Okay. So please subscribe to my channel, Math Science Topia, where I've solved all kinds of stat problems. Thanks for watching. Have a nice day. And please do not forget to watch me tomorrow when I'll come back with another interesting problem, interesting solution. Thanks for watching. Take care. Have a nice day.